All right, so this is 4.2 degrees in radians. So there's some videos here and articles if you'd like to look at that. I'll put that on the notes. So degrees in radians. Last time we talked about how to convert from degrees to radians and vice versa, radians to degrees. Today we're going to look at arc length and the area of a sector. Okay, so the arc length is the distance around the circle. Okay, not the whole distance, just this section. Okay, that's the arc length. How big is this arc? So it's basically like the pizza crust. Okay, how long is the pizza crust if you were to straighten it out? So that's what we're finding out. So if theta is a central angle in a circle of radius r, then the length of the intercepted arc s is given by s equals r times theta, where theta is measured in radians. So remember, theta is the angle, the central angle, and r is the radius. S is the arc length. In the last video, we saw theta equals s divided by r. So that's where this formula is coming from. So when theta is measured in degrees, you could also use the equation s equals pi r theta over 180. So they're converting the theta to radians with this formula. So just to remember, big note here, theta needs to be in radians. All right, it needs to be. Let's put on the notes. Have an example there in the book. All right, and we're going to be finding the arc length. So here it says find the length of the intercepted arc with the given central angle measure in a circle with the given radius round to the nearest tenth. All right, I'm going to move this over so I have space on the right side. And okay, I'll do 29, and then why don't you do 27? Notice that these are already in radian form. Okay, so here's 29. We're given the theta, and we're given the r. We want to find the s, the arc length. All right, so if you want to draw what this looks like, it's going to be an almost half, because we have 5 pi over 12, which is almost 6 pi over 12. Okay, so that's the theta, 5 pi over 12. That's the angle measurement. And our radius is our radius is 4 yards. We want to find this arc length. All right. So just remember, S equals r theta. So the arc length is equal to r theta. Our r is 4 times our theta is 5 pi over 12. And we multiply that. So here, whenever you multiply with a fraction, you always want to look at the diagonals, see if anything cancels out. And here we can simplify. 4 goes into 12 3 times. 4 goes into 4 once. So that gives us 1 times 5 pi is 5 pi on top. And on the denominator, we have 3. So 5 pi over 3. That's our... Oh, and it says to round to the nearest tenth. Ha, ha, ha. So we want to go to desmos.com/scientific. And then you can do 5. And then the pi symbol is right next to the 4, divided by 3. Hey, I like this number, 5.23, but round to the nearest tenth, 5.2. Use Desmos. All right, so why don't you try 27, and then I'll do 32 if you want to try 31. All right, so we did one with radians. That's fine. You just multiply the numbers that they gave you. Now here for 32, what this one looks like is you have a circle. You got your center there. And then the radius is 79 millimeters. And then 150. So 150 is close to 180, but not quite. So it's going to be right there. So this is 150 degrees. So we want to find S, the arc length. All right. So S equals R theta. Now you can't do 79 times 150 because it needs to be in radians. Theta needs, I should capitalize this, signify importance, needs to be in radians. All right, so theta needs to be in radians, so we're going to change that theta first from 150 to radians. So remember, you always, whatever you want should be on top. The unit that you want should be on top. So we should have the radians on top and the degrees on the bottom. So that's going to be pi radians over 180. It's either going to be pi or it's going to be 180 on top, depending on which one you want. You want it to be radians, pi is on top. You want it to be degrees, 180 is on top. All right, and then let's simplify that. Cancel out those zeros. Well, let's do the different color. Cancel out those zeros. You get 15 and 18. What goes into both of those? I would say 3. So here, 3 goes into 15 5 times. 3 goes into 18 6 times. So there we're left with 5 pi over 6. All right. But if you don't want to simplify, if you just want to use Desmos to do 150 pi over 180, it's still going to work out. It's the same thing. Okay. So go to desmos.com/scientific and do 5 pi divided by 6 gives us 2.61. So 2.6. And I forgot to put the units. The last one was yards. This one, 2.6, and millimeters. All right. Because this is a length. So whatever the lengths are here, that's the same units. Okay, so that's 32. Oh, I'm sorry. Oops. Okay, hold on. I was just finding theta. All right, so convert theta to radians first, 5 pi over 6. Let's leave it at 5 pi over 6. All right, I'm sorry. I had chocolate this morning, trying to rush. All right, so we have our theta converted to radians. All right, now we can multiply side the arc length equals r times theta. So we have our r is 79 millimeters times 5 pi over 6. Does 6 go into 79? Yeah, I don't think so. All right, so we just want to multiply 79 times 5 pi divided by 6. And when you do that, you get 206.8. There we go. That's it. So try 27 and 31. We'll put this on the notes. Do, do, do. Do, 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 do. All right. So that's that. 27, 31. Okay. All right, let's go on. All right, so here, I'm not sure if I'm gonna give you any problems on this one. I don't. Okay, but I do want to talk about it just quickly. Okay, now I'm not gonna give you any problems on this. Um, but this is something that you're gonna see in physics. If you take um, physics later on, they'll talk about angular speed, they'll talk about linear speed. Okay, so linear speed is just how fast you're going along a circular path. Okay, that's the linear speed. Uh, linear, but on a circular path, so it's kind of confusing, but there you go. And the rate at which the object rotates about a point, okay, how fast it's moving, okay, that's going to be our angular speed. Now notice it has a note there on the side, the lowercase Greek letter omega, that looks like a W. I usually put like a thing there. That's okay. Um, letter omega is usually used to denote angular speed. So we have v for the speed is going to be the arc length divided by time. And theta, if theta is the angle of rotation in radians through which the object moves during time t, then the angular speed, omega of the object is given by omega equals theta divided by t, time. Angular speed equals of rotation. So how much it rotates divided by the time. All right, that's that one. And here, the linear speed is equal to the arc length divided by time. All right. So for this one, hey, matches up. That's cool. For this one, you can look at a bike. Think of a bike, all right? And yeah, here's some questions. Find the rotation in revolutions per minute given the angular speed and the radius given the linear speed and the rate of rotation. All right. So here, all right. So for this one, you want to look at, let's do, let's do 34. All right. So basically, this is like converting units. So we're given 2 pi, 2/3 pi, and then radians per second. Now we want it to be, so we want to do some calculations to make it something revolutions over minutes. So let's change that seconds to minutes first because that's the easiest one. So what do we know? We know that 1 minute is equal to, and we want to compare it to the unit that we have for time there, which is seconds. So 1 minute is how many seconds? 60 seconds. So a way to write this is 1 minute over 60 seconds. So 1 minute per 60 seconds, or 60 seconds per 1 minute. Okay. Now over here, because seconds is on the bottom, we want the seconds to be on top so we can eliminate them. They need to be diagonal in order to eliminate. Da-dun, da-dun. And then 1 minute is going to go on the bottom there. And then radians. We want to change radians to revolutions. So what did we talked about this in, I think, the first video. It goes over here somewhere. No, 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 no. Second video. 1 radian is, there you go. Where is it? Well, one rotation is 2 pi radians. There you go. So one rotation or one revolution is 2 pi radians. So what we want to do is go back to that question. Where was the question? Where was the question? Right here? There you go. So we know that one revolution is equal to 2 pi radians. Or we could say one revolution over 2 pi radians, or vice versa. 2 pi radians over one rev. It's the same as one revolution. All right. So our radians is on top. So what we want is we want our radians to be on the bottom so it can cancel out. So one, sorry, 2 pi radians is the same as one revolution. All right. And then we just want to calculate that. So this is unit conversions. You'll do this a lot in chemistry. So we just multiply 2/3 pi times 60, and then You can do times 1 over 2 pi or just divided by 2 pi. All right. And if you want to cancel, it would be better simplifying, would be faster. 3 goes into 60 20 times. Pi is on top. There's a pi on the bottom. 2 is on top. 2 is on the bottom. So we're left with 20. There you go. Didn't have to use the calculator. Oh, sorry. Forgot to cancel out the radian. There you go. So we're left with revolutions over minutes. All right. That's number 34. And you could try, if you want to try 35 to test it out, that's fine. And here, 36. Well, it's already in minutes. So these are a little different. So omega is 104 pi radians per minute. Notice that we already have minutes on the bottom. All right, so we don't need to touch that part, but we do need to change radians to revolutions. So we use this one up on top. Now 1 revolution is the same as 2 pi radians. And the pi, there's 1 pi on top, 1 pi on the bottom, so it cancels out. And 2 goes into 104 52 times. So we're left at 52 revolutions in 1 minute. It goes around 52 times in 1 minute. All right, so that's that one. All right, so let's look at one of the linear speeds. It's like a 38. You want to try 37, feel free to. 38. Actually, 37 is probably better. Uh, 38 is probably easier, so yeah, I'll just do 38. And then you need to look at 37, let me know. So here, it says to find the radius. Remember, radius is going to be whatever the length unit is. All right. And in this case, our length unit is feet. Feet, inches, centimeters, whatever. Okay. So we want to change that. We want to change those units. Sorry, everybody. All right, we want to change um, this to just feet. Now we have that, and notice that we have the 10.9 revolutions per minute. Now we want to get rid of that minutes, and another way to write this 10.9 revolutions per minute is 10.9 revolutions on the denominator, and then 1 minute per 10.9 revolutions. So you can flip it upside down. Okay, and when you do that, cancels, cancels. So now we have feet and revolutions. Now, we don't want that, but we can change revolutions to radians. And radians is like a negated unit. I don't know. So what do we know about revolutions and radians? 1 revolution is the same as 2 pi radians. Dun, dun, dun. So this is actually feet over radians, but the radians doesn't matter. All right. It's like a placeholder kind of. So here, and when you do this A way to do this is just whatever you have on top, you want to multiply, and whatever you have, whatever numbers you have on the bottom, the denominators, those are the ones you want to have on the denominator. So you can do 10.9 times 2 pi. Okay, so if you can write this in Desmos, that'd be great. That's your answer. All right. So if you want, you can multiply it 144.2 times 1 over 10.9 times 1 over 2 pi if you want. Okay, it'll get you the same answer. It's just a little bit more work. So here I'm going to write it as 144.2 divided by 10.9 times 2 pi. And when I do that, I get 2.1 feet. Feet over radians, it's the same. Okay, radians is like a placeholder. So it's there, but it's not really there. Okay. And so notice for 37, it's a little different, but I don't want to spend too much time on that. If you want to look at 37, ask questions. Okay, if you're wondering about it, let me know and we'll go over it. Okay. Let me put this stuff on the notes. All right, so here it says, recall from geometry that a sector of a circle is a region bounded by a central angle and its intercepted arc. So we had, so what we're finding the area of that sector. So how much space that pizza slice takes up. Okay, that's our area, the whole pizza slice. And that formula is going to be the area is equal to 1/2 times the radius squared times the central angle. Bless you. All right, so here's an example from the book. And here we want to find the area of each sector. So now remember, theta should always be in radians when you're calculating with um, other units. Okay, you don't want to calculate with degrees. So now let's look at 46. And if you want to try 43, feel free to. So 46, it says find the area of each sector. Remember, area equals 1/2 the radius squared times the central angle. Now here, do they give us the radius? No, but they do give us the diameter. Okay, the diameter is 21.4. So 21.4 divided by 2 is going to give us 10.7 kilometers. That's our radius. Okay, that's our 10.7. Because remember, the radius is half of the diameter. So 10.7 plus 10.7 gives us 21.4. All right. So the first thing that we want to do is change theta to radians. Y equals, I don't know. So change theta to radians. So theta equals 146 times, we want degrees to radians, so radians should be on top, pi over 180. All right. I recommend, oh, yeah, I guess we could just use radians. That's going to be equal to, what number goes into 146 and 180? Well, they're both even, so about 2. So we get 73. Well, that's really bright. Let's use green. 73 and 90. All right. And that's good enough. So here we have 73 pi over 90. If you want to leave as 146 pi over 180, that's fine also. All right, that's theta. And our radius is 10.7. We got that already. Okay, so the area, we just need those two, and we just plug them in. So 1/2 times 10.7 squared. Let me put kilometers. You don't usually need to write the kilometers while you're calculating it, but I'll write it just so you know what our units are going to be. 10.7 kilometers squared times our theta is 73 pi over 90 radians. Now the radians again, it's like a placeholder. It's there, but it's not really there. It's not going to change anything. All right. So basically our units are going to be kilometers squared. So here we have, just calculate that. You can use a calculator if you'd like. And if you use your calculator, 1/2 times 10.7 squared times 73 pi over 90, you should get 145.9 kilometers squared. You want to try that on the calculator to see if you get it correct. That'd be good. All right. So try that. Try 43 out. If you want to try out 45 as well, this one is in radians already. So I'll do 48. 48 super quick that I can even put it right here. All right. So here's our radians. It's pointing to the inside. You see that? That's our angle. It's already in radians. Yay, this is our radius. That's all we need. R equals 43.5 centimeters. Theta equals pi over 12. It's already in radians. We don't need to change it. So here's just A equals 1/2 R squared times theta. So 1/2 times 43.5 centimeters squared times pi over 12. And there, if you use a calculator, you get 247.7 centimeters squared. And that, as they say, is that. All right, and that's it. You could go backwards and find the radius of the circle also. All right, we got a minute. I guess we could do one quickly. 51, it's green, so that means they'll show all of it. So let's look at 52, I guess. I don't know. All right, so we need our formula. A equals 1/2 r squared times theta. Our, we have our A is 808 centimeters squared. Our theta is in degrees. Let's change that to radians. So pi over 180. Zeros cancel out. 3 goes into both of those, so 7 pi over 6. 3 goes into 21 7 times. 3 goes into 18 6 times. And just calculate, put those there, substitute. Oh, if you want to solve for r, we can. Okay, so to get rid of a fraction, multiply by its reciprocal. So you can multiply both sides by 2. That'll cancel that out. And you get 2a equals r squared times theta. And then divide by theta. Cancel that out. And then to get rid of the square root, it doesn't need to be plus or minus because you can't have a negative radius. So yeah, r is going to be equal to the square root of 2a over theta. That's all you got to do. The square root of 2 times 808 over 7 pi over 6. All right, so put that in the calculator if that looks tricky because you have a fraction and a fraction. Remember this fraction, the bottom of the fraction goes on top. The bottom of the bottom fraction goes on top. So you can also write it as 2 times 808 times 6 over 7 pi if you want. Okay, either way. Let's use Desmos. So square root first. Then I'm going to hit division. 2 times 808. Go down to the bottom. 7 times pi divided by 6. Boom. 20. Oh, it says to find the radius. So we end up with 20.99. Yeah, and usually you want to write these. Oh, it's just 20.99. So you can round that to 21 centimeters. I don't know what centimeters because that area is centimeter squared. So this one, radius is centimeters. And that's it.